Today we're going to talk about correlation. Correlation is a way that we can measure the relationship or a linear relationship between two variables. So, correlation is the variable R, and the sign of your correlation indicates whether or not your data has a positive or negative association. So, if you have a positive correlation, your data is going to have an increasing trend as you move from left to right. If you have a negative correlation, then your data is going to have a negative trend, so decreasing as you move from left to right. The numerical value from R is always going to be between positive and -1 inclusive. So you can have a value of -1 or +1. If you had a value of plus or -1, this would indicate a perfectly linear relationship. If you have a value of 0, that tells us that there's no linear relationship. It doesn't necessarily mean that there's no relationship at all. It just means that that relationship is not linear. And then the value for correlation is non resistant. So this really just means that it's impacted by outliers. Just like we talked about, the mean was a non resistant measure of center. If you had outliers in your data, then the mean was pulled towards those outliers. And it's the same idea here with correlation. If you have outliers in your scatter plot, it could potentially impact the correlation. So, some facts about correlation: if you change your units, so if you change your data, maybe it was measured in inches and you converted it to centimeters, it's not going to impact the value of the correlation. I kind of touched on this on the previous slide. It only measures the strength of linear relationships. So, if your data doesn't have a linear trend, reporting correlation would not be appropriate. And then we see that non resistant here again. Some things that we want to be careful with when we're looking at scatter plots. Eventually, we're going to be looking at the least squares regression line, which is essentially a line of best fit for a scatter plot. When we do that, we want to be careful of extrapolation. So, extrapolation means that we're using our model to make predictions that are well outside of the original domain of our data set. So, for example, if you had a scatter plot, and I'm just going to kind of make a rough sketch here. We've got this negative trend, and maybe our x values in the scatter plot ranged up to 10. Extrapolation would be making a prediction for, say, an x value of 20. It's well outside of that original domain. Those predictions might not be accurate. We also potentially have lurking variables when we're talking about scatter plots. So, lurking variables are just other variables that might influence the relationship between X and Y. And so, because of these lurking variables, it could dramatically change your conclusions. Maybe it looks like you have a strong linear relationship between X and Y, but there might be a third variable that's really causing that relationship to appear. So here's an example of a lurking variable. So here they're looking at, as ice cream sales increase, the murder rate is also increasing. It's probably not the sales of ice cream that's causing that murder rate to go up. So it's not cause and effect. It's a coincidence. There is a third variable that's influencing that murder rate to increase. So, correlation and regression, when we come up with these equations for the line of best fit, are only going to describe linear relationships. And then neither one is resistant. So both your equation for line of best fit and your value for correlation will be influenced by outliers. And I'll show you a couple sketches in a minute to illustrate what I mean by that. And then if you're looking at average data, usually that correlation is going to increase because your averages are always going to kind of regress towards the mean. And so you would expect to see a tighter relationship between those variables. But then if you looked at individual variables, you're going to see a lot more spread or a lot more variability. So we also need to be careful when we're trying to establish cause and effect. Cause and effect might not always generalize to other settings. So if you see something that appears to be cause and effect in one group, that doesn't necessarily mean we can take that conclusion and apply it to all groups or apply it to another group. Usually a direct cause and effect relationship is not an entire explanation. It doesn't give us that whole big picture. Generally, there are other factors at play. And we can really only establish cause and effect in a well-designed experiment where we control for those lurking variables. And so we'll talk about experimental design as we continue throughout the course of the year, but it's just really important for us to not jump to conclusions. We see a strong relationship, but we don't necessarily have the ability to say that one thing causes another. Oops, let me go back here because I wanted to show you guys a couple sketches about this resistance. So if I had, for example, a scatter plot where all of my points here are almost perfectly linearly aligned, my correlation here is going to be close to +1. I have this positive relationship. It's pretty linear. Again, that means positive because I'm increasing, close to 1 because it's fairly linear. But then if I add another point, I'm going to change my color here. If I add this point in blue, this point would weaken my correlation. Now all of a sudden, my correlation is still positive, but this additional point that's not in this linear trend might decrease my correlation to maybe something like 0.8. Correlation can also increase when you have outliers. So I'm going to go ahead and switch my pen color back to red here. And maybe I have this cluster of points that's negative, and there's some more variability in this one. So my correlation here is negative because my trend is decreasing. And then it's not going to be -1 because those points aren't perfectly linear, but I do still see somewhat of a trend. So in this case, maybe I'm looking at negative, I don't know, point, we'll say 8. If I add in an outlier that's in line with my trend, but maybe it's very high up here. My X value is very far to the left, or if I had something very far to the right down here, these points are in line with that trend and they're going to increase the correlation. So I'm going to be closer to -1 here. I still have some variability, so it's not going to be as close to 1 as I had here, but maybe I'm looking at something like -0.85 in this case. And again, weak correlations are going to be closer to 0. So just to show you what that would look like is that maybe if I had a scatter plot here where a lot of variability, but still somewhat of a general negative trend, here I might be close to negative, we'll say 0.2. So close to 0 because there's not a very clear linear trend. We've got a lot of scatter in that scatter plot. And correlation is difficult to just kind of guess from looking at the graph. We will see how to use the calculator to calculate correlation or a website like Statlet to calculate correlation as we continue through this unit. You are going to, in just a few minutes, generate some scatter plots and then just make a guess at correlation, just so that you have some practice of looking at a graph and recognizing positive or negative correlation and whether or not it's strong or weak. So what you're going to do now is that you are going to go to your lesson 2.3 worksheet, And what we're going to do is look at some randomly generated scatter plots. So you're going to click on this link here, and I also have it linked in our assignment to go to a website where you're going to randomly generate these scatter plots. It's this Rosman Chance applet here. And you can just leave the number of points as 25, and you're going to click Generate New Sample. And you'll see here the scatter plot that's generated, and then you're going to guess the correlation from this scatter plot. So once you've generated the scatter plot, you're going to come back to your worksheet. You're going to draw a rough sketch of that scatter plot. It does not need to be perfect, just kind of a very, like I said, rough sketch, general idea of what the applet's showing you. You're going to describe this scatter plot with the strength, form, and direction, and then you're also going to make a guess at the correlation. So when I go back to my scatter plot that was randomly generated, I would say that this is a moderately strong, positive linear relationship. That's my description. And then I'm going to make a guess at correlation. I know that it's positive, so my correlation is going to be positive, and it's moderately strong. So maybe I'm going to guess that it's about positive 0.75. And then I can click check guess, and it'll tell me the actual correlation. So I can see how close I was to the actual correlation. And if your guesses aren't as close as this is here, that's not something to stress about. But again, just to get in the habit of identifying that strength and then positive or negative. So on your worksheet, you have space for 3 scatter plots. You can try additional ones if you'd like, but you don't have to draw them all. And then you're going to go ahead and answer this question here about scatter plots and correlation. And then at the very bottom, there's another link here that you can click that's going to show you some variables that are very closely correlated, but the associations are just ridiculous. There's not a way for us to say that one thing causes another. So that's something that if you'd like to explore, you can click on that link, or I will link that in the assignment for you as well. And this is the website here that shows up. So if you scroll through, there are many different relationships here, but you can see here, the first one is the US spending on science, space, and technology that has a very close relationship with suicides by these different causes. Clearly, one is not causing another, but again, it's just something that has a very close association. So something that's fun to kind of look through just so you can see how these associations definitely don't always tell us one thing causes another.